Hello, this is a demo video for MLF Machine Learning Foundation, and I will be giving you an overview of machine learning. What is it? Why it is needed? Its types, and not diving too deep into the concepts. We'll be looking at some regression classification problems, some loss functions and optimizers. So let's begin. So let us first see what is AI. Artificial intelligence. Artificial intelligence is a machine that performs a task that requires human intelligence. So basically, we are artificially giving intelligence to a machine to perform our task. AI is a broader term and machine learning is a subset of AI. Okay. Also under machine learning, we get a subset called deep learning. But we will be focusing in machine learning today. So what is machine learning? Machine learning is a machine that learns from past data to give prediction or output. Before going deep, let's analyze something. We have a ice cream vendor dataset. So ice cream vendor recorded this data. We have a day column, holiday and units sold. So basically he recorded in which day was it a holiday? Yes or no? And how many ice creams were sold? So on Monday, it was not a holiday. No. Ice cream sold was 50. Tuesday, no, 46. Like this. Saturday, yes, it was a holiday and ice cream sold was 95. He recorded 20,000 data. Now, why he did this? He wants to know that how many ice cream will sell on a particular day. So let's say on Saturday, he now wants to know that how much of ice cream should he stock up to sell on that day. Now, is it possible for a human to analyze 20,000 records and predict that how much ice cream will be sold on Saturday? Quite impossible. And this is where machine learning comes into play. So, let's revisit the definition. Machine learning is a machine that learns from past data. So, it will learn from this record consisting of the data stored previously to give some prediction. What is the prediction? That how many ice cream will sell on Saturday. Okay. This data set has day, holiday and unit sold column. This day and holiday column are called features or independent columns. Units sold is called the target column or the dependent column. So, how many ice cream will be sold or is sold depends on what day it is and whether it's a holiday or not. And that is why it is also called the dependent column. The records in this target column are called labels. So 50 is a label, 46 is a label, 53 is a label, and so on. So why we need machine learning? First, time consuming. If a human starts analyzing this 20,000 records, it will take a long time. Also, if human starts doing it, the cost of human labor is significantly more. The work is repetitive. So let's say now we have 20,000 records and after some time 10,000 more data is added. So he or she has to do this task again. Hidden patterns. So in a data set there are hidden patterns. Let's see. So we have Monday, it's not a holiday, Tuesday not a holiday, this and this. So just see Saturday, it's a holiday and the score is 95. Sunday holiday and unit sold is 102. Just see the units sold or the ice cream sold on weekends is significantly higher than on weekdays. So we can say that on Saturdays and Sundays, people buy more ice cream than in the weekdays. So it is now we say this with just two columns, two feature columns. But let's imagine we have a data set of 10 features. It becomes nearly impossible. But a machine can find hidden patterns quickly. Also, machine learning can succeed with large amount of data. It has some structured ideas for the rules. So it has some algorithms by which it finds an approximately appropriate value or a prediction. Types of machine learning. We have supervised learning, unsupervised learning, semi-supervised learning and reinforcement learning. In this video, we are going to talk about supervised and unsupervised learning. Okay, so supervised learning. It works on labeled data and prediction. What is labeled data? We just discussed about it. So let's look into it. We have a data set of house price prediction or house rent prediction. We have columns like rooms, area and rent. So rent is the target column, rooms and area are the features, and the data in this target column are called labels. So supervised learning only works with label data and it gives a prediction. So in this case, in this house price prediction, it will predict that uh, a house having this much room and some area, what will be the rent? Okay. So supervised learning has further two types, regression and classification. Regression works on continuous or numerical values like 12.0, 13.5, 18.2, like this. So it has a decimal point. It has no definite set of values. It is a value within a particular range. Classification is Classification works on discrete values of classes like true or false, 0 or 1, yes or no. So it is a definite set of values. Now, previously we talked about regression problem, that is the house price prediction or house rent prediction. Let's see an example of classification problem. Let's say we have a data set of person with a column gender, their glucose level and whether he or she is diabetic or not. So gender and glucose are the features, diabetic is the target column. So if person 1, he is a male, glucose level is 85 and he is not diabetic. Male glucose level is 105 and yes, he is diabetic. Like this we have a multiple records. This is a classification problem saying that whether a person is diabetic or not a diabetic. Okay, now let's look into two algorithms, linear regression and logistic regression. Linear regression. So as per the name suggests, it is a regression problem that uses linear function. So basically, this algorithm assumes that x and y, that the features and the target column, has a linear relationship. So it creates a linear function like this, ax1 plus bx2 plus cx3 dot 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 plus w, where this x1, x2, x3 are the features, a, b, c are the coefficients of x, which we call weights, and w is a constant value that we call bias. These features are the inputs that we give, like rooms, area, etc. And this a, b, c, the weights, are provided by the machine, the model. W is also the constant value bias, which is also controlled by the machine. So it may look like this as an example. It creates a linear graph. So for every input, it produces a y output, that is our predicted value. Now the main objective of this is it creates a y predicted value, but a model can never give a 100% accurate value. There will be some errors. So let's say if we give this input, rooms 2 and area 50, the model may give a value like 23,050. So 23,050, so like this. So let's say the y predicted value is 23,050 and the y actual that is in our data set is only 23,000. So in this case, the error is equals to 50. That is y predicted minus y actual. So like this, we calculate error. And if we sum up all these errors of this data set and calculate the average, we get a loss that is called as loss function. Now, to calculate this loss, we have several formulas, one of which is MSE, that is the mean squared error. So, it basically, f of x1 is the predicted value, y of 1 is the actual value. So, predicted minus actual, that is the error, we square it and we divided it by n. N is the total number of records. So, we basically calculate the square of the errors and calculate the average. Let's move to logistic regression. Not deep diving too much into it, but logistic regression uses a sigmoid function. So it gives a value between 0 and 1. So it creates a graph like this. Now for every value, it gives a continuous value between 0 and 1. So it can be something like 0.2, 0.7, and it has a threshold value of 0.5. So if a value is greater than 0.5, it groups it into class 1, and if it is less than 0.5, it groups it into class 0. So this is the formula. So let's say for the diabetes prediction, if the value comes to be 0.7, so it will group it into yes, diabetes. If it is 0.2, it will group it into no, not diabetes. It also has a loss function, one of which is we call log loss or cross entropy with this formula. So as we talked earlier, every model have some error, which we call the loss function. And an ideal model is a model which has no errors in its prediction, but it is not realistic. Let's move forward. So our goal is to optimize the model so that we can reduce the errors and achieve the minimum loss. We can never make the error to 0, but we can reduce it to get the minimum loss possible. And this is where optimizers comes into play. So what are optimizers? Optimizers like gradient descent will help us to reduce this loss or errors. How? So earlier we talked about MSE. So in linear regression problem, this is the MSE formula. See, this is a quadratic expression. And we know that a quadratic expression will give us a parabola, a U-shaped graph. Now, in this graph, we have a local minima or the lowest point of the graph, which in machine learning we call convergence point. So the gradient descent using its formula, it will find the lowest point. How? So let's say the gradient descent will start like this. It will find and it will continue till it finds the convergence point. And in this convergence point, it will record the weights and biases. So it will fix the model with those weights and biases which creates the minimum loss. So this is all about optimizers. What is unconstrained optimization? So it is used to minimize the loss function, but it has no restriction or constraints on the variables, one of which is the gradient descent. So its main objective is to minimize the loss. So let's see the summary. So basically when we get a data set, we have to clean the data set. Cleaning in a sense, we have to remove null values, also get rid of any unwanted values. We have to extract the features, that is the feature columns. We have to train the model. We have to predict it. And the one of the important one is calculate the loss. We have to know that how our model is performing. Calculating the loss, we will go into optimization. We will optimize the model and this process repeats and we get our final model. So this was all about supervised learning. Let's see a little bit about unsupervised learning now. Supervised learning was all about labeled data and prediction, but unsupervised learning is about unlabeled data and clustering. What I mean? Let's see this data set. So this is a shopping data set. We have person with their gender, age and products. So a person who is a female, age 18, she buys snacks and cosmetics from the shopping malls. We have a person too, that is male, age 35. He buys only groceries. Female, 42, buys groceries, cosmetics, skincare. Male, 22, buys snacks, gaming products. See, there is no target column. These three are the features, gender, age and the products. So what we are going to do is, we are going to group them or cluster them. How? First analyze it. See, this female and this male from 18 and this 22 age, they buy something in common, that is snacks. These two females of age 18 and 42, they have also something in common, that is cosmetics. Now see, this male and female, age 35 and 42, has common in groceries. So basically unsupervised learning, one of its famous algorithm is K-means, will group or cluster these customers. Why? Let's say we have launched a new product in a shopping mall and we need to know the targeted audience, whom to target, whom to actually advise so that our sales increases. And this is where we need K-means or unsupervised learning. How? Let's see from these data sets. K-means will give us clusters. How? So let's say we have age from 30 to 50, male and females, mostly buy groceries. Age 13 to 25, the teenager phase, male and female buys more snacks. Age 13 to 25, only males, they are more prone to buying gaming products. Age 16 to 25, female, they are more prone to buying cosmetics. So this is how unsupervised learning works. So let's say we have a new cosmetics product. We have launched a new makeup product. So we will target, our targeted audience is females from this age group. And that's all for today. We have covered our syllabus for today. This is an overview. MLF, we have talked about machine learning, why it is needed, types of machine learning, supervised learning, loss functions and optimizers. And at last, we have also looked at unsupervised learning.